My peoples, what's up, mathletes? I thought it would be good for some of you to see how a quadratic equation is worked out using the quadratic formula, how to solve for x using the quadratic formula. This is going to be the largest formula that we'll have used up to this point. And while the order of operations haven't changed, it does require a bunch of steps. So here's an example that we'll go through real quick, and maybe this will help you in your assignment that is still on Google in our Google Classrooms, along with a problem with the answer written out. But again, for those that want to see step by step, here you go. All right, so this equation is written in standard form, which you do need. If you're going to use the quadratic equation, you have to make sure the problem is written in standard form. And you want to right away label what your A, B, and C happen to be. I wish this would catch and focus a little bit here. Well, maybe that's better. Bring it up. Anyway, remember that if there is no number in front of a variable, but the variable is there, like let's say it was just an x, then b in this case would be 1. But for this problem, b would be a positive 9. Now, I kind of cut you a break here, and all of these numbers are positive. But negative numbers do kind of pose some trickier situations as we use the formula here, and I'll show you why in just a moment. So establishing what A, B, and C are, then our next step is to use the quadratic formula itself. Now, you can solve for x 3 different ways in what we have learned in the last couple weeks here. You can solve by factoring or unfoiling, however you want to call that. You can solve algebraically when there's no b term, and you can solve by using the quadratic formula. We're going to learn all three. All three have their places, and next week we'll determine when is the best time for those 3 and why we use them. But the quadratic formula can always be used in any kind of quadratic equation. Once you know what A, B, and C are, then you can replace those numbers into the formula as needed. Let's see, try to get this straight here. So I'm going to go really step by step here. So negative, whatever B is, well, B is a positive 9 in this case, so it's going to be negative 9. Plus or minus. Okay, we're going to use both of these here eventually. And again, we'll explain why that's the case next week. But b squared would be 9 squared minus 4 times a times c. 4 times what a is times what c is. Okay, and then that's all over 2 times a. All right, so being able to plug in A, B, and C correctly is obviously pretty important. So this is what the formula looks like without the variables. Without variables, it's just a matter of order of operations. Now, since all of this is under the square root sign, this is where we are going to start, because it is as though all of that is being wrapped in parentheses. And when multiple operations are wrapped in parentheses, you do what's inside first. Like here, the parentheses are just to separate multiplication. Here, the square root symbol is acting as a grouping symbol. So we're going to look in there first. So my first step of simplifying, negative 9 stays where it's at. The plus minus stays. 9 squared, 81. Minus 4 times 5. 4 times 5 is, what is 4 times 5? 4 times 5 is 20. 20 times 4 is 80. All right, and since 4, 5, and 4 are all positive, we're just going to subtract what these three numbers are together. If one of these were negative, we would get a negative result, and minusing a negative would turn to addition. That's why you kind of have to be careful with negatives, but this problem doesn't have any negatives, so we don't have to worry about it at the moment. And then 2 times 5 is 10. Okay, next step of simplifying. -9, plus or minus. 81 minus 80 is 1, and the square root of 1 is 1. So that simplifies down pretty quickly and easily. Fortunately, the square root of 1 being 1, that does not give us a decimal answer, so that's going to make calculating this go a lot smoother. Now, here's where we have to branch into the plus and to the minus. So -9 plus 1 is going to be a -8 divided by 10, which reduces to -4/5. That is one solution. X has an intercept at -4/5, or -0.8. If we subtract -9 minus 1, that gets us a -10. My pen is running out of ink. Over 10. -10 divided by 10 simplifies to -1. So the two solutions that we have for x are at -1 and at -0.8, or at -4/5. Either of those would be fine. Fraction or decimal, doesn't matter to me. They're both correct. So the two solutions, I would keep in fraction form. That's just me. X equals a -1 and x equals a -4/5. Okay, this is not a point. The point would actually be -1, 0, because they're x-intercepts, and -4/5, 0. And that's more if we were graphing, which we're not for these problems this week. We're not going to graph anything. But here's what I could tell you, and this is just to kind of wrap up what we know so far. The x-intercepts would be here and here. They're pretty close to each other. The y-intercept is going to be at a +4. It's going to open upward because a is positive. It's a +5. And because there's a 5, it's going to be pretty narrow. It's going to be a pretty narrow parabola. The only thing we don't know is the vertex. But again, save a little something for next week. Okay? Now, I wouldn't expect anybody to go from here to here all in their head. That's an unreasonable request. You should show at least 2, maybe 3 steps of simplifying along the way, just because there is so much to keep track of. All right? If you have any questions, go ahead and post in the comments. Otherwise, I'll let you loose. Unless somebody in the comments wants to say, I'd like to see one more example. If you want to see one more example, go ahead and post something. Otherwise, I'm going to wrap this up and try and keep it under 10 minutes. 10-minute lesson would be awesome, especially for my long-winded self. Things to keep in mind, again, if one of these or if some of these happen to be negative, you have to really be conscientious of your negative rules when you're adding and subtracting and multiplying and dividing. So, and then if this number ends up being a number that doesn't have a perfect square, like the square root of 5, that's going to be a decimal amount. Okay, so decimal amounts are still okay to get. This one just happened to be 1, not a decimal. If you just wanted to put this for your answer, that's totally cool. If you wanted to take it one more step and write them as points, that is also acceptable. The camera's being a little fuzzy, little jerks. Okay, I hope you guys are doing all right. We've got this lesson and we've got one more And that's it. Everything's due by June 12th. All right. Take care, you guys. Talk to you soon.